This is CP3 lesson 3. Okay, we only have a few lessons left. I think we're down to like 6 or 7 lessons for the year. That's it. Yeah. And only 118 days until September 4th when you get to come back and get gains in higher algebra, except for Spencer, who I'm going to fail, so he does geometry again. Spencer?
Hey, I won't fail. Oh, yeah.
All right, so let's do this. Today we're going to write the equation of a perpendicular bisector. That means we're going to write the equation of a line. Okay, and we're going to find the circumcenter of a triangle. So let's get started. How do we find the circumcenter of a circle? What? Well, the circumcenter of a circle is the center of the circle, right? Mm-hmm. It is equidistant from what?
Each side.
Not each side. Each vertex, right? So this was the example we spoke about the other day where we had our high school and 2 other high schools were having an event, and we wanted to put an aid station that was centrally located. What are the properties? What are the properties of the segments that go through this point? Do you remember? Do you remember those properties? What does this blue segment do? It cuts this side in what? In half, and it forms a perpendicular angle. So it forms... Yes, perpendicular bisectors. So it forms a 90-degree angle. That's the first thing it does. And the second thing it does is it locates the midpoint of, let's call this side AB. All right, so if this point right here were A and this point right here were B, the point where this crosses right there is the midpoint. So a couple things we need to be able to do today. We need to be able to find a midpoint. And the other thing we need to do is be able to find a perpendicular slope. So let's jump into the next page and look at how we do that. Okay, a couple formulas, right? Midpoint is x plus x divided by 2, and y plus y divided by 2. That should be review. Slope is y2 minus y1 over x2 minus x1. Or more formally, you may have seen this as the change in y over the change in x. Anybody recognize that? Yep. Okay. The triangle just means change, delta. Right? Here are the 2 ways we could write out the equation of a line. Okay, the more typical method that we're going to use today is going to be this point-slope form. Okay, and what that is if I have a point, let's say I have the point 4, 7, and I have a slope. Let's say the slope is, I don't know, -3. I could write the equation of a line using this form. It would be y minus 7, that's my y value, equals my slope, -3, x minus my x value. Okay, that'd be the equation of a line that goes through point 47 with a slope of -3. If I wanted the equation of a line that was perpendicular to that, what would I do with my slope here? Opposite reciprocal, right? So I'd flip it. So a line that goes through 4, 7, but is perpendicular to this line would have an opposite reciprocal slope, but it'd go through the same points. Yeah, you did. Opposite reciprocal. Right on. So what would be true about these 2 lines is that the first one and the second one are perpendicular to each other. All right? They go through the same point, and they're perpendicular to each other. Okay, that's a little review on slope, midpoint, and the equation of a line. Okay, so we're going to just jump right in. Triangle RES has vertices 0, 0. Let's put up 0, 0 here. This is point R. Okay, point E is 4, -6. So I'm going to go over 4 and down 6. How about that? And point S is 8, 4. Over 8, up 4. Okay, so what we have here is a triangle. Looks like that. Find the equation of the perpendicular bisector of RE. Perpendicular bisector of RE. All right, so if I want to find the perpendicular bisector, I want to do two things. I want to find first the midpoint of RE. Agreed? The second thing I want to find is I want to find the slope of RE. And then we're going to analyze that in a moment, okay? So how would I find the midpoint of RE? Perfect. So I'm going to do x plus x divided by 2 like Wyatt said. So x, right, this x right here, plus 4 over 2. I have another 0 for my y, and a negative 6 over 2. Let's find that midpoint. Do a quick calculation. What's 4 divided by 2? 2. What's negative 6 divided by 2? Negative 3. So this right here is the midpoint. Midpoint of RE. All right, I'm going to draw that a different color. So 2, negative 3. If I would have sketched it perfectly, there it is. All right, that's our midpoint. Okay, so now I know a point that is going to be on my perpendicular bisector of RE. I know a point. What else did I need on the last slide in order to find the equation? Yeah, I have a point here, 4, 7. I need to find a slope. So let's check it out, see how we're going to do that in the second piece. Let's find the slope of RE. So y2 minus y1 over x2 minus x1, which comes out to be negative 6 over 4. Can I reduce that? That would be negative what? 3 over 2. Now that's the slope of RE. I want the perpendicular slope. What would a slope perpendicular to negative 3 halves be? Yeah, flip it over and change its sign, so 2/3. Okay, so this would be the slope of a line perpendicular to RE. So just for a moment here, appease me here by, oh, come on, go away, thing. Go over here for a second, so I got more space. That'll work. Okay, I'm going to draw a line perpendicular to RE that goes through this midpoint. Kind of looks like that. Do you agree that the slope of this would have to be 2/3? Yeah, I think we can all agree that. And it's going to go through this point, which we determined was 2, negative 3. Goes through that point, 2, negative 3. So now we can write the equation of this orange line. Okay, so let's write the equation of this here real quick. I'm going to do it in orange. Okay, it's going to be y minus something equals slope times x minus something. So it's going to be y minus what? Negative 3. Good. And then 2/3, right? That's our slope. X minus 2. Now we can clean that up a little bit. So I'm going to do so. Minus a negative, that should be y plus 3 equals 2/3 x minus 2. If you want to leave it right there, that is totally okay. This is called point-slope form because you need a slope and you need a point. That's the equation of our perpendicular bisector. let's move on to another example here. Find the coordinates of the circumcenter. Okay, so the circumcenter. Now, wait a minute. It gives me two equations. These equations right here and here, what do they represent? Perpendicular bisectors. So what's the name of the point called where perpendicular bisectors cross? It's called circumcenter. Yeah, no, you're good. You're good with that guess, but it's called the circumcenter. So what am I looking for? I'm looking for where these two lines do what? Where they cross. I could graph them and maybe get a decent estimate of where that's at. So let's do that quick. Let's graph the red one first. What's the y-intercept of the red one? 1, yeah. And the slope is 1/2, so that'd be like up 3 and over 6. I'm just going to do that, right? So that would be our graph of the red perpendicular bisector. And the graph of the blue one is -1/2 for the slope, but it's up 4. So y-intercept of 4. And let's go down 1 over 2, down 2 over 4. Oh, I don't think this is going to cross at a very nice place. Not one that's easy to estimate by graphing. This would be the circumcenter, but it's going to be hard to estimate that location. I would say, I don't know, would you say this is a decent estimate, 3 and comma 2.5-ish? Yeah, decent. My graph is okay, but what's an easier way I can do this? What are these both equal to? If they're both equal to y, what's true about them? They can be set equal to each other. Let's do it. So let's take 1/2. I'm going to do, instead of 0.5, I don't like that. That can be looked at as 5 instead of 0.5. I'm going to do this, and I'm going to set it equal to -1/2 x plus 4. And I'm just going to solve for x. So I'm going to add 1/2 x to both sides. So you guys, in this process, if I ever give you the equation of the lines, you should say, thanks, I don't have to do anything graphically. I just have to do algebra. So 1/2 and 1/2 is 1x. And at the same time, I'm going to subtract 1 from both sides. So then on the other side of the equal sign, what do I get? 3. So it looks like x equals 3. Ooh, this is like solving systems of equations. I'm halfway there. Where could I plug a 3 to get an answer? To get an answer for y, right? Because I have half of the solution. I'm pretty good with my estimate. What should I do? Where should I plug that? Into x, right? In either of the two original equations. I'm going to use the red one. So y equals 1/2 times x plus 1. And we know x equals 3. Therefore, y equals, what is that, 1.5. Half of 3 is 1.5 plus 1. Looks like y equals 2.5. I was right on with my estimate. Right? That was a pretty good guess. My graph was good enough. So that would be the coordinates of the circumcenter. And we'll be done. Okay. Oh my goodness. Look at this table. It's got plenty of information. I don't put things into these tables that you will not use. So each of the pieces that are there for your help. Yeah. So I'm not just like putting a bunch of fluff out there to make you do more work. I do that to my kids. Okay. Okay, so find the coordinates of the circumcenter for the triangle with these vertices. So you see how you got A to B here? 0, 0 to 5, 2. We're going to use those points for the things in that row. So the midpoint. What 2 points should I find the midpoint of? Those two. Yeah? So if I add the x's, right, I'll add the x's here. I have 5 plus 0, I divide by 2. And I add the y's, I have 2 plus 0, and I divide by 2. Looks like my midpoint would be 2.5, comma 1. Right? 2 divided by 2 is 1. 5 divided by 2 is 2.5. Oh, slope. Oh no, what points should I use? The ones given. I'm only like focusing on this because this is these things happened. Okay. Someone's like, well, I don't know what points to use. Use the ones that I gave you. Oh, okay. All right, so finding the slope, I would do y minus y. So how about 2 minus 0 over x minus x, which is 5 minus 0. So it looks like I get a slope of 2/5. Okay, cool. Slope of the perpendicular. I don't know what happened to that. I must have, the width of that column was just not quite. But it's perpendicular. I had a student ask me, what is perpendicular R? Well, it'd be the slope that's opposite reciprocal of this thing, right? Which would be negative 5/2. Okay, cool. Why did I find that? Because I'm going to use it. Okay. So let's write an equation using the things I just did here. I have a point and I have a slope. Someone asked me last year, well, which slope do I use? Well, which one did you calculate most recently? Right? That's what I would say. So I'm going to take y minus 1 equals slope x minus x. Boom. There's the equation of that perpendicular bisector. Would you with a neighbor do the same thing for the second one? And then we'll find out where they cross. Go. Hey, so we did the math on the second piece. It looks like we got a midpoint of 1, 2, a slope of 2, which changes our slope to the perpendicular of negative 1/2. And we get these two equations. Now, the first equation, what I'm going to do is I'm going to take this thing, right, y minus 1, and I'm going to bring that 1 over to the other side. And I'm going to do some distributing, so bear with me for a second. Oh gosh, that's 5/2. That's positive 25/4, which is 6.25. And then I add that to it. I think I get this. Yeah. Okay, if I were to put that in y equals mx plus b form, why would I do that? Well, because I want these to be in a form that'll work well for me, where I have both set equal to y. So it looks like I'll get negative 1/2 x plus 2 plus 1/2 is 2.5. And at this point, now we're going to solve a system of equations. It's kind of yucky, but let's do it. You can just sit back and relax and watch as I work this out. Since both of these are equal to y, I'm going to set them equal to each other. So it looks like I get negative 2.5x plus 7.25 is equal to negative 0.5x plus 2.5. I'm going to get x's on the same side, so I'm going to add 0.5x on this side and do the same over here. So that gives me negative 2x plus 7.25 is equal to 2.5. How many people just love the decimals in their life? No. Well, this problem really does it for you, doesn't it? Okay, so I'm going to subtract 7.25 from both sides. Oh boy, do I get 4.75? I think negative 4.75. And I'm going to divide that by negative 2. So I'll get a positive value. I think it's 2.375. Ew. Ew. Okay, so I've found half of the coordinate. It's 2.375. What I'm going to do is I'm going to then plug that back into one of these two. I think I'm going to use this one. I'm going to use this one right here. So y equals negative 1/2 x plus 2.5. I might need my calculator on this one, because these numbers are about to get uglier much quicker. I think on the test, we make the numbers work out much nicer. But this example just is what it is. 2.375 times 0.5 plus 2.5. Yeah, I get a yucky number. I get y equals 1.3125. Whew. And although it's not pleasant, that would be the point of intersection of those two lines. Like, subscribe, $19.48 to GNC to the 100th sub. We're still about 30 short, so you got some time this year. Yeah.